Section 2.4 is on set operations and Venn diagrams with 3 sets. So the first example, even though we're going to be seeing 3 different sets, is actually a review of what we did in the last video with those set operations. So before we begin, let's just keep in mind that if you see the apostrophe, that's the complement symbol, and it means what's not in the set that it's attached to. It's not in that set, but it's still in the universal set. If you see the intersection symbol, that means the matches between the 2 sets. If you see a union U, it means to simply combine the 2 sets together. So keeping that guide in mind, we also want to keep in mind the order of operations. So as I look at the first question, and actually for all these parts, we're going to use the following sets. It says given that the universal set is little a through little f. Set A is A, B, C, D. Set B is little a, B, D, F. Set C is little b, c, f. So for this whole slide, we're going to be using these sets. And it says find each of the following sets. So starting with question A, we have A union parentheses B intersect C. So if we think back to the last video, we said that when you have a whole mix of operations like this, you always do inside parentheses first. So step 1, inside parentheses, we have B intersected with C. So here are B and C above, and intersection, we said means matches. Where did these 2 sets B and C match? What do they have in common? So when I look up here, I see that they both have a little b and they both have a little f. And we still have those set brackets around each of these steps and each of these answers. So we just figured out the answer to what's in parentheses is the set with little b and little f in it. All right, so we've taken care of all of our parentheses. However, we still have another set operation outside the parentheses to take care of. Normally we would do complements next, but I don't see any apostrophes. So step 2, the only thing left is to take A and to unite it, do a union with our answer to step 1. So step 2, we're going to do the union that's outside the parentheses. So set A was A, B, C, D. And I'm going to do a union or unite it with my answer to B intersect C, which was really my answer from step 1. We already did that. That was BF. That was my parentheses B intersect C answer. And union means to combine the sets together. Who cares if they match? So when I combine these together, I have an A, B, C, and D. And I have an F. After each step, I constantly check back to the original question. I just took care of all the operations outside parentheses, so I've done everything. So this must be the final answer, is the set with little a, B, C, D, F in it. Taking a look now at question B. Question B has parentheses A union B, close the parentheses, intersected with more parentheses A union C, close those parentheses. So we always do inside parentheses first. You might be saying, but we have 2 sets of parentheses. So when that happens, we go from left to right. So we're going to do the parentheses on the far left to begin, which is A united with B. So here we're A and B. Keep in mind our memory trick for union, because it's opening up, so that's a union U, is to combine the sets together. So I'm going to just simply combine sets A and B. So between the two sets, we have A, B, C, D. We already listed A, B, and D, so the only thing left that said B contributes is F. So between the two sets, we have A, B, C, D, F. So the first set of parentheses is done. Now, the second set of parentheses is step 2. We're still on the parentheses step with order of operations. So now we're going to do A union C. It's another union because the U is opening up. So if I go back up here to the original question, here is A and here is C. So we still got to combine since it's union. So we already said set A has A, B, C, D in it. And let's see, I've already listed B and C. So the only other element set C has is an F. So I get A, B, C, D, F when I unite A and C together. All right, so that set of parentheses is done. Step 2 in the order of operations, we would do complement. That's the apostrophe next, but we don't have any complements in this question. So the last step of the order of operations is everything else that's outside the parentheses. And the only operation left outside these parentheses here is it's an intersection symbol. So I'm pretty much going to intersect my answers to steps 1 and 2. So here's step 3, if you will, is to take care of this intersection between my answers to what was in the parentheses. This is opening down is why it is an intersection symbol. Our memory trick for intersection was matches. So I'm going to have to erase some of my other work here to make room. For the final answer. Let me rewrite. This happened to be step 3. Whoop. There we go. So when I match these two sets together, they both have A, B, C, D, and F. So they have all their elements in common. A, B, C, D, F. And yes, we still need the set brackets around them. So the set with little A, B, C, D, F is the final answer because there are no operations left to take care of from the original question. So what you have at the end of the last step is always your final answer and the only thing you would type into the answer box in MyMathLab. Let's try one more because these can be a little bit tricky. I actually had one more on this slide, but you can't see it because it's too far on the bottom. So I'm going to erase my work here to create room for this extra example. We're still going to use all the same sets, so this is still example 1. And I'll just call this part C. So we're going to do set A intersected with parentheses, B union C complement, close the parentheses. So to begin, as usual, if you see parentheses, we always do inside parentheses first. However, we have two set operations inside parentheses here. We have a union and we have the apostrophe, the complement. So which one wins? Well, the complement is higher up the chain than union. It's higher up the hierarchy. So when you have several different operations inside parentheses, you would do the complements first from left to right. So I'm going to do C complement first. And C complement means what's not in that set, so it's not in set C, but still in the universal set. So here is C, and we're comparing it to the universal set. So if set C had BCF in it, let's get rid of BCF. And the elements that are left in the universal set are A, D, and E. Or think of complement as the opposite. So what's the opposite of set C? So what's the opposite of having the letters BCF in it? Is A, D, and E are all the other letters in the universal set. So there's C complement. Done. We are still inside the parentheses. So now step 2, we can take care of that union. We're going to do B, set B united with C complement. So set B was A, B, D, and F. And we're going to do a union or unite it with C complement, which was A, D, E. And the union means we are going to combine the sets together. So when I merge these two sets, the B and the C complement from step 1 together, we have an A and we have a B. We have D, E, F. So you put the two sets together, combine them, A, B, D, E, F. So pretty much we have everything except C when we look at that set. So now I go back to the original question. I've taken care of everything inside parentheses. So the only thing left to do in step 3 is to take set A and intersect it with my answer to what's in parentheses, which is what was at the end of step 2. So I'm intersecting it with that union from step 2. So set A was A, B, C, D. And I'm going to intersect it with, I'm just going to draw an arrow, that answer to step 2, the answer to the union that was in parentheses. Our memory trick for intersection was matches. So where do these two sets match? Well, they both have an A and a B in common. They also have a D in common. So I get a final answer of the set with little A, little B, and little D in it. That's what I did last. There's nothing left to do in the original question. Yay! So that is my final answer, set with A, B, D. As you can see, I just constantly chip away at it. But the two most helpful items to keep in mind are the set order of operations and the memory tricks for complement, intersection, and union. As long as you have those two things nearby, that can help a lot with these bigger, longer set operation questions. For example 2, it says that it wants us to construct a Venn diagram illustrating the following sets. So we're just going to draw a Venn diagram that has 3 sets. The universal set is on the bottom of the question for a change. So U for universal set equals the numbers 1 through 10. So I'm going to go ahead and get my Venn diagram box ready to go. I have no artistic ability. I know. It's sad. I can't even draw a box. And then I'm going to throw some sort of a U in the upper left-hand corner. I made mine a cursive U. You can just have a normal U there. I do a cursive U so that it's not confused with union U, is why I'm doing that. And now we have 3 subsets, A, B, C, so I need 3 circles for a change. Even my circles are kind of sad, especially that bottom one. But throw them on there, and they should all be joined together a little bit in the middle there. And you do need labels on the 3 circles, A, B, C. And the trick to drawing any Venn diagram, it doesn't matter if it has 2 or 3 or more circles, is you always want to work your way from the inside out. So to begin step 1, I'm going to think about the intersection between all 3 sets. So where does A intersect B intersect C? So where do all 3 circles overlap? And it's going to go right here in the dead center. So we go work our way from the inside out. Kind of like if somebody dropped a pebble into water and it kind of spirals out, the imprint it has in the water. So thinking about, remember, intersection means matches. So where do all 3 of those sets match? Well, let's see. Set A was 1, 3, 6, 10. Set B is 4, 7, 9, 10. C is 3, 4, 5, 8, 9, 10. So when I compare those 3 sets, they all have a 10 in common. And that's it. So it's technically the set with 10. So just a 10 in common. You can see that they all have that 10. And it's going to help in the long run. As soon as you put a number in the diagram, get rid of it from all the sets. Even the universal set, get rid of it. We'll see why by the end of this question that's going to pay off. You don't have to write out like step 1 like I did here. In fact, I'm going to erase it. I'm just showing you that that's technically the intersection, the overlap between all 3 sets. They all overlap at 10. All right, so that's step 1. Now step 2, we're going to do the 3 spots that are in the inner ring. So if I start up here, I'm going to do what's left in the overlap between sets A and B. So if I look at A and B, A still has a 1, 3, 6 left. B has a 4, 7, 9 left. They don't have any elements left in common now that we've taken care of the 10. So I'm going to leave that spot blank. In fact, I'll even erase the little dot I put there. Going clockwise, now I'm looking at where do B and C still intersect at. So B and C, B has 4, 7, 9 left in it. C has 3, 4, 5, 8, 9 left in it. So they both have a 9 in common. And I just put it anywhere in that remaining overlap. They also have a 4 in common. So actually both 4 and 9, we're not allowed to put commas in a Venn diagram, just the elements themselves. I know it looks kind of weird. I kind of mushed the 4 and 9 together. But as soon as you put the 4 and 9, get rid of it from the sets. As soon as you put it in the Venn diagram, that is, get rid of it, slash it from all the sets, even the universal set. So 4 and 9 have been taken care of. And we are still on step 2, the inner ring. So now we got to do any overlap between A and C. So A has a 1, 3, 6 left. C has a 3, 5, 8 left. So they both have a 3 in common. So I'm going to put a 3 here. And then get rid of it in the sets above, even from the universal set. So step 2, we did the inner ring. We said we're working our way out. So now step 3, we're going to do the outskirts of these circles. So what's left in A? And here's why I kept saying, make sure you slash, get rid of what you've used in the original sets, because now it's easier to see what's left over. So what's left over in circle A is 1 and 6. So go ahead and put a 1 and a 6 down, and then we get rid of it. And get rid of the 1 and 6 even from the universal set. I know it kind of looks like 16. That's okay. Just plunk them down in the diagram and you're good. What's left in B? Well, we have a 7. So put the 7 there and then get rid of it. Get rid of it. And what's left in C is 5 and 8. And then get rid of them. And then the last step, step 4, is easy to forget. Here's why I made such a big fuss about don't forget to even slash what you've used from the universal set, because we got to figure out what goes in the box, the universal box, but outside the circles. So that's step 4, and I see that I still have not taken care of 2. So that there should be a 2 somewhere outside the circles, but still in the box. And you might want to just check real quick that the numbers 1 through 10 that was in the universal set, all those numbers should be somewhere in the box. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, I see them somewhere in the box, so that's a good sign. We have the answer correct as well. But again, we work our way from the inside out. We started at the dense center with step 1. Step 2 was the inner ring. Step 3 was in the outskirts of the circles. Step 4 was in the box outside the circles. And that whole diagram is done. It definitely matters how you label your circles. Your answer might look different than mine if your circle A was on the right or on the bottom. If you oriented your circles different, that's okay, just so the numbers, the elements, are still in the same spots in those circles, you would be good to go to get the answer correct. And finally, in this section, we can also use Venn diagrams to visually prove equality. So we are finally, for this type of example, going to use the Roman numerals, the labels, because we're not listing out elements. So let me just show you what I mean by this. So example 3, we're going to use the Venn diagram to solve this exercise, all parts A through C. So starting with part A, it says which region, so which Roman numeral label, represents parentheses A union B with that apostrophe, that complement floating outside the parentheses. So, putting it all together, the complement is actually being applied to the union inside parentheses. Union, the memory trick was to combine the circles together, or what's inside the circles. So if I'm going to do a complement to a union, visually, it then means the opposite. So the opposite of inside the circles is obviously what's outside the circles. So the region that's referring to is region 4 with the Roman numerals. So region 4, everything outside the circles, represents the complement of the union of A and B. Okay, now let's take a look at question B. So question B says, which region represents A complement intersected with B complement? So I'm going to use some color coding to see it better. So I'm going to do A complement in red. A complement means everything outside of circle A, what's not in A. So that's regions 3 and 4. B complement, I am going to use the aqua pen for. So B complement means everything outside circle B, what's not in B. So that would be 1 and also 4, because 4 technically is outside of circle B, so regions 1 and 4 would be B complement. And then finally, they want us to intersect those two complements. So what area do they have in common? Where do they overlap or match at? In other words, where do you see both colors, both the red and the aqua colors? Well, the only region that they have in common that I see both colors on is region 4. So they have region 4 in common between those two complements. And now it says based in part C, it says based on parts A and B, what can you conclude? So because we got the same exact regions, no more, no less, we can say that these two items are equal to each other. So, part A was asking us for A union B complement, A union B in parentheses, complement. And then part B was asking us for A complement intersected with B complement. And I can conclude that these two expressions are equal to each other because they represent the same exact regions. If you're going through any of these questions and you get extra regions, like let's say if for part B, let's say I got not just region 4, but I also got region 3, When I get to part C, I would say they're not equal because they don't represent the same exact regions. So they have to represent the same exact regions, no more, no less, in order for you to say that parts A and B are equal to each other.